Welcome to episode 3, where finally we're going to build the logical framework of our battles. By the end we'll have our units taking turns to deal damage to, first just themselves, so they'll all kind of just punch themselves in the face until they're all dead. Obviously not our final goal, but an important first step that goes over the full framework of our, and really any turn-based battle system. So most turn-based systems work largely on this logical loop. Number 1, whose turn is it? Whether it's a linear turn order or you're using speed values or whatever else, you need to decide whose turn it is. It's a turn-based system after all. Number 2, what action should they take? Our player characters will eventually want to use a menu to pick an action, and our enemies will use an AI script. For now, we'll just have them all decide to do an attack action. Number 3, do the action, play the animations, effects, etc., resolve the action, and deal any damage. Number 4, has the fight ended? Are all the enemies dead? Is the player party all dead? Have you escaped? Have you satisfied any conditions that mean we should end the fight? If so, end the fight. If not, then we go back to step 1 and increment the turn order and do it all over again. So that's the flow we're going to build today in an initially pretty bare bones fashion. Before we get into it though, we need to create our action library and our attack action so that we have something to work with. In the game data script, I'm adding global.action library, which is going to be one big struct containing a struct for each action that can be performed by a unit. The first one we define is the attack action. We fill it out with a whole bunch of properties. The nice thing with structs is we can sort of add these in any order. Some actions can have properties that others don't even define. As long as we're careful about checking for that in our code, we can get away with being somewhat messy. But the attack action is a nice example of a very basic action, so let's go over the properties that we'll have for this and most other actions. It will have a name, which is what it will show up as to the player when picking an action, a description that we'll use to draw text, this 0 in curly brackets will get swapped out for the name of the unit that is using the action. Submenu decides if the action is a top level action or if it belongs to the item menu or the magic menu, etc. -1 here means it's a top level action. Some targeting behaviors, which we'll come to in a later episode. User animation that tells us what animation to use as defined in the party and enemy data. Effect sprite is what effect sprite we should play, in this case just this little bonk animation. And effect on target is whether or not that sprite should be played at the coordinates of your target, or whether just at the screen 00 because it's a big screen-wide animation. You'll notice a couple of these are set to this strange mode.never and mode.always. This is a simple enum I've made for almost boolean values, as this case comes up a lot. Where I want a flag I can set to always on, always off, or it depends, and that's what this is for. These literally translate to being 0, 1, and 2, but it makes it easier to read and remember to use a constant enum. Last but not least, we have the func property of an action, which is the function that actually gets performed when this action is resolved. So we pick targets, do an animation, play an effect, and then what? The function will generally always take the user and targets as arguments, and targets will always be an array to make things easier. So even if it's a single target, we work with targets 0. In this case, we work out how much damage we want to do. I made up a basic formula based on the user's strength value. You can do whatever you want. For now, I'm just going to keep things simple and reduce our target's HP directly. We know it's only one target, so we'll just use targets 0 and reduce its HP using max to make sure we don't go below 0. Later on, we'll make a custom function to change our HP since it comes with a lot of shared caveats like what to do at 0 or max HP that is easier to not have to rewrite per action, but for now, this is fine. Now we've got an action to work with, let's build our game loop. We'll open oBattle's create event, and I'm just going to declare some new variables ahead of time. Most are self-explanatory, some we'll come to in a bit, but these are the variables we need. Something I really want to mention, by the way, it will be obvious to some, but to those it isn't, I didn't build the game or write any of the code in the order I will show you it. The order in which I show you steps is designed to balance saving time and teaching things as clearly as possible. So when I define a bunch of variables at the start like this, it's just to get it out of the way. But when I'm coming up with this stuff, it's usually as I'm writing the code they get used in, and I'll have to come back to declare the variables as I go. Again, kind of obvious, but I only point this out as I don't want you to think most programmers are able to come up with all the variables and logic they need right away and declare it all ahead of time. We model it all out more or less the same way as one another, so don't feel like you're missing something there. Anyway, variables added, we want to drop down to the bottom and add a whole bunch of state functions. That's right, our battle object is becoming a state machine. Thinking back to our flow loop we talked about at the start, we already know whose turn it is initially, so we start with wanting to select an action, which we'll do in battle state select action. This will be mostly about creating menus for the player or letting our AI pick an action for the enemy. Once we've picked an action and targets, we need to start that action, which we'll use a function for called begin action, taking the user action and targets arguments. We make this a function because we'll either want to call this directly from the select action state for our enemies, who just run a script to pick their action, or from our player menu, which we'll come to in later parts. But they'll both do the same thing, which is what we'll want to put in this function. Then once we start an action, we want to wait while we play the animations, sounds, whatever, and resolve the actual effects of our actions, which we'll do in battle state perform action. Then we'll progress to a battle state victory check to see if the battle should end. And if it shouldn't, we'll progress to battle state turn progression to decide who should go next, and then loop all the way back to selecting an action. With these functions declared, we'll add battle state equals battle state select action here at the end. Important to declare this last so it knows what battle state select action is. And our battle object is basically just going to call whatever function is currently in battle state each frame. This makes it really easy to keep the logic of each step clean and separate. So let's go to battle state select action and add the following. I grab the current unit as a local var just to make typing it easier. This state will get much longer in later episodes, so this is very worthwhile, trust me. We check if that unit is unable to take a turn for whatever reason, and if it is, we skip straight to the victory check state and use exit to end the function early. Otherwise, we know we are able to act. Eventually, we'll either create a menu if we need to, wait while the player picks an action from a menu, or have our enemy script pick an action. Right now, we just want to have the unit punch itself in the face, so we'll write begin action, unit ID, global.action library.attack, and unit.id. So what will that do? In begin action, we'll add the following. We'll set some of these variables we declared earlier to be whatever action is in progress for whichever unit and target. If, like we did here, we only included a single unit ID as a target, we convert it into an array. This just lets us be a bit messier like this in case we forget to pass our targets as an array. We set battle wait time remaining to an arbitrarily picked battle wait time frames value. This will be used to just add a small delay between the action finishing and the game moving on. Some games give you settings that control this kind of delay, but it's an important delay to have some amount of, or the player can just very quickly lose track if lots of enemy units act in a row. Some games definitely overdo this, Pokemon games, I'm looking at you, but adjust to your taste. I've gone with 30 frames. Then we set the user's acting value to true. This later tells our perform action state that we're still in the midst of doing an animation or whatever. Then we set an animation to play, assuming one was defined in our game data for that action, and that same animation was defined for the unit using it. This means our game won't crash if a unit tries to use an action it doesn't have the animation for. It will just use the action without playing an animation. Not all actions will necessarily require an animation after all, but that also makes it especially important to have some amount of delay set up to prevent the action just going off in a single frame. Once this is done, we move on to the perform action state. In that state, we want to add the following, and bear with me because this is the biggest code block of the video. Right, so if our current user is currently acting, we check to see if the animation has ended, which we can do by seeing if the image index exceeds the frame count. If it has ended, we reset ourselves to the idle sprite and set acting to false. Then we check to see if the current action has an effect sprite defined. If it has, then we check to see if we should play that effect on top of each individual target or play it as a screen-wide effect. We can work that out by asking if effect on target is mode.always or if it's mode.varies, and we only have one target. This means you can have a spell with different animations depending on if it is being used as a single or multi-target. If we're playing it on individual targets, we loop over those targets with a for loop and we create an instance of a new object called oBattleEffect at each one. We're just using depth for this to keep things simple, but worth noting that for now these effects will just draw over the top of everything without respecting the unit render order. We use the original depth of the units as they were placed, so at least multiple effects going off at once should be roughly the right order, but yeah. If we're not playing it on targets, we check to see if we have an alternate no target sprite for the action, which we don't, but we'll add examples of this later, and then we just want to create one instance of the battle effect at the room position of our battle object. At the same time we do all of this, we want to do whatever our action should do, so we call the func that we defined for that action. In this case, our attack action, which just reduces the HP of the target. If we perform this state and our current user is no longer acting and no battle effect is currently playing, we reduce battle wait time remaining until it hits 0 and move on to the victory check state. Whew, yeah, that was kind of a lot. Now you might have noticed oBattleEffect is not red because we haven't made this object yet. Thankfully it's an extremely simple object, so just make a new object called oBattleEffect, add the animation end effect, and add instance destroy. That's literally it. It's just an object that we create, give it a sprite, and then when that sprite finishes playing once, we destroy it. Okay, now I think we've done more than enough already, so we'll make the rest as simple as possible. In the victory check for now, we're just going to skip this and have our fight continue forever, so just set battle state to the turn progression state. In the turn progression state, we'll do the following: add 1 to turn count, add 1 to turn, and then check to see if turn is higher than the number of units in the turn order, and if it is, go back to turn 0 and increase round count by 1. I don't think I end up really using this round count thing for anything, but it seemed worthwhile to track, I don't know. Then finally set battle state back to the select action state, and that's the loop. Now to set it all going, we just go to the step event and add battle state with a pair of brackets. This will call the function currently in battle state. Be very careful in your states to make sure that when you change state, you use the name of the function without brackets. We're just putting a reference to the function into the state variable, we're not calling the function. You'll get some weird errors if you forget to do this. Most commonly, you'll see something like you're not able to call battle state as it thinks it's been set to undefined or something, so just be extra careful with that. I make this mistake all the time, it's very annoying. If we run the game now, we should hopefully be able to start a battle and watch our units pummel themselves to death. You'll see the current turn move around via the yellow highlight, the health of our player characters will drop over time, and as each unit dies, they'll stop taking turns. The enemies will disappear from the list, although their sprites will still be there, and the character names will turn red. Now there was a lot of code, so don't panic if you don't get this result. You'll just need to go back over the steps, make sure you understand as best you can how they work, be patient, and be precise. Debugging can be a pain, but just hang in there. I hope this has been helpful so far. We've touched somewhat on every aspect of the system in this episode, so hopefully this gives you a good overview of what to expect as we proceed. Creating menus to let players pick actions and select targets, adding more actions that do different things, actually winning or losing the fight, using actions with MP costs, or using item actions that we have a limited number of, etc. It all fits on top of this foundation, so if you understand this episode, the rest will start coming together relatively easily, I think. We'll see how we get on. Thanks to my patrons for funding this series. Remember, the source code is available for each episode as well as the final game project, so check that out if you haven't. Thank you of course for watching, and I'll catch you all next time.